I'm Renee with Buncombe County Soil and Water Conservation District. Each year we sponsor environmental field days, and we host that for 5th graders within Buncombe County. And each year we have 8 stations. And here today we have a macroinvertebrate station with Diane with Cooperative Extension. Next we have the water cycle station with Dottie Schumann's Montreat College students. And next we have a soils station with William Miller with NCDNA with the soils department. We also have WNC Nature Center here with a wildlife station. We have Erika Schneider with Sundance Energy here to do the solar system station. Colburn Earth Science Museum is also here doing a weather station, and Montreat College always does an agriculture station. And also we want to say a big thanks to Montreat College, who allows us to use this field and site each year. It's a gorgeous day out here, and we're thankful that they let us use that.
My name is Diane, and I am the Mud Creek Watershed Project Coordinator, which is a watershed project aimed at cleaning up, restoring and protecting the Mud Creek watershed, which is in Henderson County. But my project is hosted by the Extension Service, so I'm an extension agent and I work in Buncombe County as well. So our station here today at the field day was on benthic macroinvertebrates. That's a big science word that means the bugs that live in the bottom of the stream, okay? Macro means big enough to see without a microscope. Invertebrates are insects and worms and things like that, as opposed to frogs and salamanders and things that would have a backbone, okay? The reason we're interested in these benthic macroinvertebrates is that they are indicators of how healthy a stream is. The general idea is if you sample a stream system and there's lots of things living in that stream, then that suggests that the stream is supporting all that life, right? It's providing really good habitat, so it suggests that it's a healthy stream. If you sample and you don't find a good diversity of organisms, especially the ones that are super sensitive, then that suggests that they've died out, and that means that the stream is not supporting them. So it's an indicator that there might be some water quality problems that we would want to look into further. So it's kind of like the canary in the coal mine, and it's a good first assessment before you spend a lot of money doing chemical monitoring and testing for for metals and things like that. So it's also a great activity for young scientists because it's really fun and cool to go catch bugs and look at them. So for the field day, we didn't have a lot of time, so we did the sampling ahead of time. We take a net like this. This is called a kick net, and we just go in the stream and set it down in the stream and disturb the substrate a little bit, just enough so that the current will carry any critters into the net. And then we transfer the organisms from the net into bins. So for our activity, we had stations set up around with about 4 students per station. They each had a little bin with some bugs. And we use paintbrushes so that they don't damage the bugs as they transfer them. They get to collect their bugs out of their bin and put them in an ice cube tray in order to separate them out. And then we have a dichotomous key. It's a chart with a whole bunch of pictures on it. And it's kind of like playing 20 questions where you say, does it have any legs or does it not have legs? And then if it does, you follow that path, and then there's another set of questions. And you keep following through the questions until you identify the bug that you have. So that's all we had time to do today. If a scientist, with the Division of Water Quality were doing it, it would be a little bit more meticulous, a little bit more scientific. But it's a real good introduction for the students on how biologists do field science. So we hope they're getting a little bit of some science in there, and also just a really great experience in the outdoors and interacting with the stream and with wildlife, and hopefully they come away feeling like science is cool.
My name is Cody Walker. I'm here with Montreat College. I'm an environmental science major. We are here to explain the water cycle, where it starts from a lake and evaporates. Evaporation condenses, precipitation, and all those main terms that explain the water cycle. And our main goal is to just get this information to these kids so that it'll help them understand how the ecosystem works.
I learned a lot about the water cycle, like that it starts out like water, it starts out like in a lake, and how it gets evaporated in vapor. Then it condenses into a cloud by grabbing onto like dust. And then when the cloud gets heavy enough, it just rains, and then it just starts all over again.
My name is William Miller. I work for the North Carolina Department of Agriculture, and I'm here at the Buncombe County Conservation Field Days where we're trying to teach kids a little bit about resource conservation. And I'm doing a soil station where I impress upon kids that soil is made up of different size soil particles, sand, silt, and clay, that they behave dramatically differently, and different implications as to how those behave and how that affects agriculture and resource conservation, erosion, and things like that.
Sand is the biggest by a lot. If that was a sand particle, that would be a silt particle. That tiny little dot you can't even see, that would be a clay particle. And they give you an idea of how different they are. If a sand particle was the size of Mount Whitney, silt particle would be two statues of liberty stacked on top of each other. A clay particle would be about a 6 foot tall person. So if we're all little clay particles right here, these mountains you see behind you, they got to be somewhere in between the silt and the sand particle, right? So it's a big old difference. But don't feel bad. Everybody always says, unless they already know it, clay's the biggest. This is easy. Look at it. I can see that. This guy's job is so easy. I don't even need to touch it. That one looks a little smaller. That one's the smallest. I'm done. My hands aren't even dirty. I'm a good soil scientist. But I didn't give you all the information you actually needed. What you're supposed to do when you texture these is kind of rub your fingers in there, move them around, drop all the big things. That residue you're left with, those are the individual silt particles. That's what you're supposed to texture. You might actually still even have some of them bound to your fingers right now.
Hello everybody, my name is Eli, and I've got an eastern box turtle here with me, and he and I were at the Buncombe County Soil and Water Conservation Field Day today, talking to 5th graders about soil and water. And one of the connections that we make is with wildlife and the way that they use soil and water. We're talking a little bit about food chains, and use this box turtle to kind of demonstrate the way that animals transfer energy from one level of the food chain to the next, and the importance of approaching wildlife respectfully so that they're able to remain in that food chain and do the important jobs that they do in nature. So the food chain game we played involves each member of the game being each level of a food chain. So we start with the plants, and everyone's a plant, and they play rock, paper, scissors, and the winner of the game moves up the level of the food chain. So the participants in the game are energy, and they move from one part of a food chain to the next, starting from plants, moving on up through the animals to the very top, and then they cycle back through.
My name is Erika Schneider, and I've been spending this beautiful sunny day with 5th graders here at Buncombe County Field Days. And my station and challenge was to talk to them about energy. I work for a company called Sundance Power Systems, and we do renewable energy, primarily, mostly solar. But the intention of being here today and participating in education is to plant those seeds that will get this generation looking at energy use, how it's impacting their lives, and ensuring that we have clean, healthy sources of energy into the future. So it's a real challenge to do that in 20 minutes, but I feel like it went really well. Try to create the big picture of what energy is and how we're using it. And then we primarily talk about our electrical energy use. For many of them, it's a surprise to realize that we're burning coal primarily in this region to generate electricity. And we talked briefly about the impacts of using that as our primary energy source. What was really a key point of what we looked at today with energy conversions is recognizing that almost all energy on this planet comes from the sun. And indeed, we were able to trace the energy stored in coal back to sunshine too, that it is stored solar energy as a fossil fuel. And so we took that and led into, well, can we be using the sun more directly to provide some of our energy? And we saw that it's really not difficult at all to create hot water with simple technology. And then my little green dancing grasshopper is about the best tool I know of to see that direct conversion of light into electricity, and they always enjoy that. So we are seeing this transition, but I believe education and Sundance greatly supports outreach, even though we're a small company, because it's really critical to that shift to clean energy for our future.
Today's theme was soil and water conservation, and we were thinking about how does weather and how does the water cycle lead to things like pollution and surface runoff, and how does that lead to things in our drinking water. And we played this fun interactive game where the kids just think they're running around and having fun, but we're secretly sneaking science education into their brains. So after they leave this game, they realize that the things they do impact us now and the things in the future. And the Colburn Earth Science Museum is dedicated to teaching small children high-level science, that by the time they become adults, they will be very well off in their science literacy and science education, because that is becoming more and more important as our planet has more and more people on it. Understanding how can we preserve and conserve our water and resources for the future generation, for these kids and their grandkids. And what might seem like just a fun game or a fun afternoon in a field might actually be the day that changes a kid's life and shows them that we are actually part of a big global community. And we all have to work together in order to make it work.
We're trying to do hands-on learning about the environment and how we can affect it and how we can help it.
Well, I learned today a lot about precipitation and a lot about clouds and weather. So I learned mostly how precipitation, it's where a cloud, it gets heavy enough, and then water, which it falls out of the cloud as rain and goes into the soil, and yeah, and when the soil has enough water when it's filled with soil and has too much water, it will create a runoff, which is where the gravity, it pulls the water down into the like a low place, like a streamer. Yeah.
On one station they had some livestock, like pigs and cows. They didn't actually have cows, but they had pigs and chickens. It was really cool.